Okay, so we're going to take a look and determine whether some of these sequences listed at the bottom of the page either converge or diverge. So remember that our definition of a sequence converging is that the limit as n goes to infinity of our sequence exists and is finite. So we need both of those things. So we're going to start with, I should want to start with number 11. So I have a sub n is n squared plus 1 over n. So some of you will be able to do this limit off the top of your head. If you're struggling with it a little bit, there's kind of two ways you could approach that. The first is to look at the degree of the polynomial in the numerator and denominator. So you have an n squared over an n. This n squared is a greater degree polynomial. And so if that happens, then we know that the limit as n goes to infinity is going to also go to infinity. If you wanted to break this up algebraically, we could split this into two fractions. So I'd have an n squared over n plus a 1 over n. So remember, this is like 1 divided by the federal debt, so that's going to be basically 0. And n squared over n simplifies to just n, and so that is going to infinity. Okay, and because of that, we would say that this sequence diverges. Okay, let's take a look at number 13, because we can kind of use those same principles again, where we look at the biggest power in the numerator denominator. So I'm going to take the limit as n goes to infinity of 3n to the fourth minus 7n over 5n squared plus n to the fourth. And yeah, you are going to have to write all that out. So just keep that in mind when you're working on your homework. So I'm going to take these two biggest powers. So this is going to be equal to the limit as n goes to infinity of 3n to the fourth over a positive n to the fourth. And so then this is just equal to 3. Okay, so in that case, this one converges. All right, so let's tackle some of these other ones. Let's start with a sub n is equal to 0.8 to the n. All right, so I'm going to look at the limit as n goes to infinity. And instead of 0.8, I'm going to write this as 4/5. Okay. And the reason for that is if you're not sure what this one does, if we think about how fractions work, so if n was 2, I would be squaring both these numbers. So I would have 16 over 25, which is smaller than 4/5. And I could keep multiplying these out. So I could multiply each time by a 4/5, or I can put that in the table in my calculator. So I have, let's see, 4 divided by 5, or 0.8, either way, raised to the n. If I look at the table, oops, okay, I see 0.8, 0.64. Okay, so getting smaller, smaller, smaller. So, and these are positive numbers, so I know when I multiply them together, I'm going to keep getting a positive number. So this thing is not going to go negative. So my limit here is going to be 0. And so this one converges. All right, let's look at number 12. So looking at the limit as n goes to infinity of 1 plus negative 1 to the n. So what I know about this is that this term is going to alternate between negative and positive. So when n is 1, the value will be 0. So a1 is 0. When n is 2, this is going to be positive, so I'm going to get a 2. When n is 3, this will be negative again. And so this thing is going to alternate back and forth between 0 and 2. And it's going to keep going. And so this limit does not exist. And since the limit does not exist, the sequence diverges. Okay, and then we have one more on here. So I'm going to be looking at the limit as n goes to infinity of 1 minus, now e to the negative n can be rewritten as 1 over e to the n. And then all of that's going to be over 1 plus 1 over e to the n. So e to the n is getting really, really big. So this is basically 1 divided by the federal debt on like steroids. So it's definitely going to 0. So at least with a 1 over 1, so this limit is equal to 1. And I would say that this sequence converges. Okay. So we have, for sequences, we have converges, diverges, diverges, and then two converges.